Hello guys, I apologize this has taken so long. It has literally been a totally packed schedule ever since I got off the plane. So I apologize. You do have until Monday, and again, this should not take you too incredibly long to get through. So this is going to be pretty straightforward. We're just going to be doing a quick comparison of the inner terrestrial planets and seeing how these planets compare to Earth. I'll be looking at a couple of the recent Mars rovers and also some of the planned Mars rovers. So this is a video of the transit of Mercury that happened on Monday.
Mercury about to make a rare appearance across the Sun's face. Our solar system's smallest planet will be visible on Monday as it passes between Earth and the Sun, a rare spectacle that only occurs a few times a century. While the Earth takes 365 days to orbit the Sun, Mercury only takes 88 days to make the journey. Skywatchers worldwide will be able to witness part of this voyage on Monday. Mercury passes between Earth and the Sun 3 times a year, about every 4 months. However, Mercury's tilted orbit prevents us normally seeing this journey. As Mercury's orbit is inclined 7 degrees to the plane of Earth's orbit, it's rare for the 3 bodies to line up so that Mercury is in our direct line of sight to the Sun. In fact, this only occurs 13 to 14 times a century. The next time we'll be able to view Mercury's transit will be in 2019 and 2032. Mercury, which is about 3 times smaller than Earth, will be just 1 of 158th the width of the Sun's disk, so its movement across the Sun is only visible with high-powered lenses. Mercury will take about 7.5 hours to move across the Sun, beginning from 7:12 a.m. Eastern Standard Time until around 2:42 p.m. An interesting phenomenon that can be observed is the black drop effect, which occurs when Mercury's edge forms a teardrop shape as it touches the Sun's edge. Mercury's flit across the Sun will be visible through much of Western Europe, Northwestern Africa, and the Americas, while other areas of the world may see part of the transit.
So we can classify the differences between the inner and the outer planets based on their internal structure and a lot of other characteristics like their moons, their densities, their distance, their temperatures. And we call the inner planets terrestrial because they're Earth-like. So the inner planets, the terrestrials, all have these distinct characteristics of being very small. Trying to find my pointer here. Of being small, of being very high density, of being rocky. They're differentiated. They have solid surfaces as opposed to the outer planets that don't have those things. The outer planets are condensed gas. They're very large. They're very low density, and they're not differentiated, meaning they don't have core mantle crust. And we know that the deeper we go in the Earth, the more metallic structure we get. We have a metallic core, we have a molten mantle, and we have a lighter silicate crust. So the surfaces of all the terrestrial planets can be altered due to surface processes. Now, these do not apply to every planetary surface, but these are just some contributing factors which can alter the surface of a body. One thing that all of them have in common and can be altered by is impact craters. We see that on every terrestrial planet. On Earth, we see that it is tilted. On the Moon, we can see the obvious impacts of the craters. On Mercury, we can see that it has no crust, and on Venus, it rotates backwards due to an impact. Volcanoes are not something that everybody has. For example, Mercury having no crust can't really have volcanoes. However, the Moon, even though it doesn't have volcanoes, there are also flooded impact basins. The Maria, which we talked about earlier in the semester, which is a result of an impact that was flooded with mantle material. However, there isn't tectonics in order to have volcanoes in the traditional sense. So we have plate tectonics here on Earth, and we have surface erosion. There is no surface erosion on, say, the Moon because it rotates so slowly. So on the Moon, erosion is solely from impacts. So in looking at planetary surfaces, we can generally date the age of the surface based on crater counting. This is something that I had to do also in my asteroid research and why I'm out here, because we can tell not just planetary surfaces as a whole, but regions of those bodies which are older or younger. So regions that have many craters, we can see this on the moon, or asteroid bodies, we can tell that those are older. If there's fewer craters, those generally tend to be younger. And how that works, because obviously the body as a whole is the same age, is you can have resurfacing events, whether that be surface erosion, whether that be a volcanic eruption, or in the case of the moon, asteroids, or even places on Mars, that can be due to impacts that shock generally the surrounding rock. There can either be lava flows that come up from underneath, or it can shock, blacken, and change the geochemistry of the surrounding rock, and thus obliterate any prior evidence of impacts. And that's something we see on all of the terrestrial bodies, is you have this process of resurfacing. So here we can see on the moon, just comparatively, if you remember back earlier in the semester, we talked about the Maria, we talked about the highlands. We can see here the highlands are generally higher, they're lighter. You can see a lot more craters here as opposed to the Maria, which are smoother and lower lying. So we can tell that these areas underwent a resurfacing somewhere in the area of bombardment about 3.1 to 3.8 billion years ago, whereas these areas did not. So they're retaining all of the impact signatures throughout the entire geologic history of the moon. And we can tell that because there's a greater density of craters. So this will be a question you'll have to answer here in a moment. So Mercury, our innermost planet, if you look at pictures of Mercury, a lot of times they have what looks like an error in the images. And if you look closely at this, you can see it looks like there are strips of the Mercurian surface that have been laid together like a mosaic, and that's actually exactly what's happened. The best pictures of Mercury were taken by the Mariner missions in the early 70s, and also by some probes by the Soviet Union long before we got there. After we made it first to the moon, they made it first to all of the inner solar system. They made it there in the 60s. They were the only probe to penetrate the atmosphere of Venus, and they did that in the early 70s. We have not done that at all, and we're 50 years later. So a lot of these images, since they're a mosaic, they had to literally link these together like tiles, and that's why it looks a little bit disjointed. But 50 years later, this is what we got. So Mercury is a very small body, but it was likely much larger initially. Mercury is pretty much entirely core, so the outer layer was blasted away. So that's a result of impacts, whereas you can see that the remnant of the surface is still heavily impacted. So this has a huge temperature range, the largest in the entire solar system. Obviously, closest to the sun is where you get the higher end of that spectrum, but then on the nighttime side is where you get that decrease. Mercury has a very interesting rotation. It was thought to rotate synchronously with the sun, such as our moon does, meaning a day there and a year are the same. However, it has a very different resonance. It's called a 2 to 3 resonance. So that means that for every 2 rotations, it goes around 3 times. So its day is longer than its year by 2 times. It takes 2 days to 3 years to actually go around 2 times. So we can see, looking at the interior structure of Earth when it's compared side by side to Mercury, we can see the Earth is this fully differentiated structure where we have the inner core, we have a mantle, we have an upper mantle, and we have a crust, all of which retain these very different density and compositional signatures. Whereas when we compare side by side to Mercury, we can see that Mercury is predominantly core. So we have a inner core, we have an outer core, an extremely thin mantle and crust, which again tells us that this was a result of a catastrophic impact, which would make sense because Mercury being closer to the sun, the potential impactor was likely accelerated not by Mercury's gravity, but by that heliocentric distance and being pulled towards the sun, which would have accelerated it, making it a significantly higher velocity impact than a normal terrestrial body would have, because those impacts are a result of the gravity of the body, which is proportional to the mass, and usually that wouldn't be very big for a low mass body, but in this case it was accelerated by the mass of the sun. So we can see that Mercury has 0 moons. That is likely again due to that consequence of the gravitational pull of the sun. They would not be in a gravitationally stable location around Mercury. And we can see that if we look comparatively at Venus and Mars, Venus and Mars compare to Earth much closer than Mercury does. Venus has been called the twin to Earth, whereas Mars has the exact same axial tilt as Earth. And they both have some characteristics that are somewhat Earth-like and some that are not. For example, Venus is incredibly poisonous. If you took one inhalation, your lungs would be vaporized. And that would be if you could withstand the atmospheric pressure, because there's 90 times greater pressure there than at Earth's surface. It is strong enough to crush a bus. And if that didn't kill you, the gases there, the sulfuric acid in the atmosphere, is enough to melt a bus. So there's enough to crush a bus and melt a bus. It's not a place where you would want to be breathing. Venus has an incredibly thick atmosphere, whereas our atmosphere is generally about 0.026 or so percent CO2. You can see that Venus's atmosphere is a whole lot more of that. So because of that, Venus has this runaway greenhouse effect. And remember, we discussed this a couple of classes ago. Because Venus started out slightly warmer because it was closer to the sun, it was unable to retain liquid water. So just that difference meant that it could not pull and extract CO2 out of the atmosphere the way Earth did, because so it couldn't absorb it into things like rocks, didn't have anywhere else to extract that CO2. So it's just been concentrated in the atmosphere and accumulating and making the surface hotter and hotter. So when we look at Venus, we are only seeing this external cloud cover. We don't see the interior of Venus underneath those clouds at all. So it is always very warm, even though it is the second planet from the sun. Venus is the hottest planet. It is about 9/10 the size of Earth, and it's always around 900 degrees Fahrenheit, or about 600 degrees Celsius. It is not a place that we would want to be. It is not habitable. And the Soviet Union in the late 60s, early 70s sent the Venera probes there. They had multiple Venera probes that penetrated not only the atmosphere of Venus, but also landed on the surface, took the only images that humans have ever seen of the surface of Venus. They were fully aware that it was likely going to melt and be disintegrated and crushed by the pressure, but we did receive some images back. So these are some of those images from the Venera probes. And this was a Soviet mission that ran from 1961, you read that correctly, to 1984. So Venera 4 and Venera 7 successfully penetrated the atmosphere. The 7 actually landed on the surface. So 61, I mean, we didn't even have people in space, and they already had a planetary probe. So the Soviet Union had a very successful planetary stint of missions from the 60s to the 80s. However, everything has kind of been failed ever since then. So we can see that this is somewhat of an altered computer image, but we can see what looks like volcanic domes. It looks like they have some sort of, not carbonate, but some sort of basaltic rock there, so it's very possible that Venus has tectonics. We have been able to observe externally from ground-based telescopes and from things like Hubble. We've been able to see what looks like lightning. Lightning going off in the clouds, which could be a result of active volcanism on Venus. But again, this is something that we're not going to send something there just for it to be crushed. This Venera probe, Venera 7, that landed on the surface, it was only able to transmit data for about 4 minutes. So we can see in black and white, we can see the contrast, we can see the broken up rocky surface, likely a basaltic surface, and here we can see the front of the probe in the minutes of its life. So here is this video that I'm going to attempt to play.
Recently, astronomers have built up a detailed picture of Venus's atmosphere. Imagine a probe hurtling toward the planet. What would it see? 50 miles above the surface, it hits a thick layer of cloud. But this is no ordinary cloud. It's made of vaporized acid, corrosive enough to burn through steel. Scientists believe that the acid clouds are a byproduct of Venus's violent history. Gigantic volcanic eruptions blasted billions of tons of sulfur high into the atmosphere. There, it mixed with water vapor to form concentrated sulfuric acid. As the probe breaks through the upper atmosphere, it slows to make a low pass over the surface. The terrain is dominated by dormant volcanoes that tower 3 miles into the atmosphere. Deep channels, forged 1 million years ago by molten lava, stretch thousands of miles, one longer even than the River Nile. Probe sensors reveal an atmospheric pressure 90 times greater than on Earth, large enough to crush a car. But the biggest problem is temperature. The atmosphere is nearly all carbon dioxide. Just like on Earth, this gas acts like a pane of glass in a greenhouse, letting the light through, but not the heat out. On Earth, increased carbon dioxide levels are causing small rises in temperature. But on Venus, they have pushed the temperature to over 900 degrees Fahrenheit.
So Mars is the closest analog to Earth and the obvious candidate for when we look at colonizing another location. Mars is the inspiration for SpaceX, which, if you have possibly been living in a hole for the last couple of years, that is owned by Elon Musk, who was the founder of PayPal, sold PayPal to start SpaceX, is also the owner of Tesla and Solar City, which he uses all of that revenue in order to work on his launch vehicles. He is starting in Texas. He is going to have the first private launch pad. I've been to the facility. It's amazing. They make everything from the seat belts to the nose cones, and it's all 3D printed. It's pretty darn awesome. They don't pay crap, but it's a pretty amazing facility. And they're really revolutionizing the launch vehicle business and also just commercial space as a whole. And his whole goal is that he is going to be buried on Mars. So in about 40 years, I mean, he is planning to get there. So Mars has a very elliptical orbit. It is also tilted at exactly the same tilt as Earth. So it is tilted at 23.5 degrees. If you remember, that is the tilt of Earth. Mars happens to be tilted at exactly the same tilt. Which is crazy because Mars also is not always tilted that way. It has a wild precession. We believe that Mars' tilt can vary by up to 50 degrees. It does not have a moon that's proportional in size the way ours does in order to stabilize that orbit. So that axis can vary greatly. But there are Martian seasons. However, because Mars' orbit is so elliptical, it's summer and winter. Their difference is about 45 days. It's significant. So it comes closer to the sun and then further away. So it can have significantly longer winters. Mars has a very thin atmosphere. While it is high in CO2, it is only about 5% of the atmosphere of Earth. So because 1%, I'm sorry. Because there is so little atmospheric pressure, if humans were to actually go to Mars, we would need to create not just an artificial atmosphere, but we would need to have processes that would produce a Martian atmosphere at all. There is currently not enough atmospheric pressure to support water in the liquid form, except in the most low-lying areas, which are under the greatest amount of atmosphere. If you can see these regions right here, this is something that's very unique to Mars that we'll be talking about. That's called the Tharsis Bulge, this guy being the largest volcano in the solar system. This is the Valles Marineris, the largest canyon in the solar system, and these were both observed by the Mariner missions, which gave us a really beautiful view of Mars and can be observed from a clear night with great viewing conditions from Earth. So Mars has 2 moons, Phobos and Deimos. The Latin derivative of these words are phobia and demon. These were 2 children of the god Mars that the sons were feuding for his attention and ended up killing each other. Lovely story. But Phobos and Deimos have very different orbits. One is significantly closer. That one is Phobos. Deimos is significantly further away. Deimos is spiraling away from Mars. Phobos is spiraling towards Mars. So they have different origins. One is likely captured and one is likely a chunk from an impact that was thrown out and then captured within the orbit. So they are very different sizes and they're very different distances, and because of their distances, it appears as though they overtake each other in the sky. So that's where those names came from. This is the Mars Curiosity rover. I'll be talking about that in just a second, but we can see a lot of the equipment aboard it. Curiosity is there right now. It was only launched about 4 years ago, and this is the whole science suite I had a student whose dad is the manager of this mission. I got to see it before it was launched, and I've seen the replicas. You can go to the Mars yard down at JPL, and you can see the replicas of this. It's pretty amazing. He has a Twitter feed too, so you can actually follow Curiosity on Twitter.
Strong evidence gathered from a Mars Express spacecraft has revealed that there once was an ocean that covered part of the red planet known as Mars. Sediments reminiscent of an ocean floor was detected within the boundaries of previously identified ancient shorelines on Mars. The research argues that there were possibly 2 oceans on Mars. The first one 4 billion years ago when the conditions were warmer, and the other 3 billion years ago. The more recent ocean would have been there for 1 million years. The water then would have been frozen back in place and preserved underground again, or turned into vapor and lifted into the atmosphere. The new research gives a new understanding of the mysterious red planet that once was possibly blue. Yet the question remains, where did all the water go? Sally Turner, IB Times TV.
So Mars, as I said, is about 1/3 the size of Earth. We can see in this image here the northern cap. I'll talk about those in just a second. But Mars, being further from the sun, also has this extreme temperature range. And you can see that, yes, there are places that get up to 70 degrees. However, that is extremely brief. Those are lower lying areas. Don't think that there's 70 degrees there and it's nice and comfortable. That's generally only about 4 hours of the day between 10 and 2, at which point 215, it would drop more to the negative 220 range. So you have a very narrow window in which EVA or any sort of outside of habitat activities could actually be conducted. There are 2 full frozen polar caps on Mars with very different compositions. And during the summer, these can sublimate, meaning going from solid to gas and skipping the liquid phase entirely, which releases CO2. So that is likely the source of the continued CO2 in the atmosphere. And Mars has this very interesting topography. We can see this dichotomy in the northern and southern hemisphere. We can see that in the northern hemisphere, the blue is lower lying areas. Your yellow and your reds are the higher areas. So right here in the red, this is the region with Olympus Mons, also called the Tharsis Bulge, where this area extends out about 10 miles higher than the rest of the planet. We can also see this very low-lying area that is a large impact. And we can see that if we just compare as a whole the southern hemisphere to the northern hemisphere, we don't see any of those structures in the northern hemisphere. And there could be a few reasons for that. It is possible that the northern hemisphere had a large impact, resurfacing the entire thing and covering it in magma. It is possible that there was a volcano right here, the Olympus Mons, that also had an eruption of magma, which resurfaced. However, that wouldn't explain the elevation. It is also possible that the northern hemisphere had an ocean covering the entire part of it, and the sediment washed to the southern hemisphere and created these areas right here that could be beaches. So if we look in the visual, we can see the Tharsis Bulge in this region here, and even with decent ground-based telescopes, this is what we would see. We could clearly see this canyon, we could clearly see this region of the Tharsis Bulge with the 3 other volcanoes, which on Mars are called Paternae, and this guy, the largest, is Olympus Mons, the largest in the solar system. So here is Valles Marineris. We could see this rendition right here that looks like it actually has watermarks. We can see, compared to the Grand Canyon, which is only about 18 miles wide, 1 mile deep, this guy is 1,000 miles wide and can be as much as 4 miles deep. This is nearly the size of the entire U.S., just comparatively for size. And it takes up about 1/3 of the entire planet. So the Martian caps are very different in their sizes and their characteristics. We can see here, just looking at the northern cap, the change between October of 96 and then March of 97. We can see how much that changes. The northern cap is mainly water. However, it does have some CO2 there as well, and when that sublimes, goes from a solid to a gas in the summer, that releases a lot of that CO2 that can contribute to warming of the planet. It can also contribute to some dust storms. For example, when Mariner 4 arrived at Mars, it was so covered in dust they had to actually wait before able to get some good pictures of Mars. It took them about 3 days or so. The southern cap is significantly smaller, and it has a higher concentration of carbon dioxide and also a lot of dry ice there. So they have different characteristics. However, due to the elliptical orbit, the northern cap ends up being in the sun for a lot longer. So it has a higher rate of sublimation than the southern cap does. But also due to that elliptical orbit and the precession, due to a lack of stabilizing large moons, the southern cap will eventually be the one that gets bigger. So it seems as though there are areas within the caps where you have growth and recession and growth and recession. So it seems like they swap. There are times when the northern cap is larger and the southern cap is larger. So looking at some rovers here, we can see the Mars yard right here. This is Curiosity. Here we have Sojourner, which is about the size of a microwave, and this is a mock-up of Spirit and Opportunity, which were twin rovers. Spirit and Opportunity were launched in the early 2000s. They were only supposed to have a life cycle of about 2 months. Opportunity is still going. Spirit is not. It got stuck in a crater, and it was no longer able to power its solar panels. Obviously, we did not send C-3PO to Mars, but it would be awesome if we did. He's standing next to a mock-up of Spirit and Opportunity. So our rovers have successfully gotten bigger, and our spacecraft have gotten smaller. So it's kind of interesting how we did that. So our earliest rovers were very, very small. And even this guy here with Curiosity, the budget for a rover to Mars is significantly less than even some launch vehicles to get them there. So Curiosity landed on less than a $500 million budget. And Curiosity landed also because someone had a very intuitive and curious child. They could not figure out how to land this rover there and do it for cheap. They talked about a parachute, but it would not slow the descent enough since there isn't enough atmosphere there. So we'll watch a video of this in just a second. But it was a child that came up with the airbag concept for essentially dropping Curiosity on Mars, and that kept the cost super low. So it's one of the most efficient and cost-effective missions that NASA has ever launched. And the goal of Curiosity was able to find whether there was ever conditions that could support microbial life ever on Mars. So this picture right here is called the Sandy selfie. This is an extension. He's holding out his arm. You can't really see the arm, but this is one of the most famous selfies that Curiosity took. He sends back selfies on his Twitter feed. I assume that it's a he. And this is taken within the Gale crater that Curiosity is exploring. We have a couple other missions coming up. Mars 2020 is set to be the Curiosity replacement, except that Curiosity was only supposed to go for 2 years, and it's been extended indefinitely. We've been very lucky with our rovers. Also, the Mars InSight mission, which is launching in 2018, which is going to take some seismic measurements. It's actually going to drop something from about 50 meters with the intent for it to submerge itself in the Martian surface for us to gain a better understanding of what the interior of the planet looks like. Because it is very possible that Mars used to have tectonics, so it has volcanoes, but that it's now tectonically dead. We want to see what constitutes a dead tectonic planet, because we don't really want that to happen to us. That would decrease our magnetic field and lessen our protection from the sun.
Can explore Mars, it's got to get there first. The last stage of the launch vehicle gives the spacecraft a final push and spins it up for our 8.5-month cruise to the Red Planet. Ten minutes before hitting the atmosphere, the cruise stage separates and final preparations for entry begin. The atmosphere at about 13,000 miles per hour, the spacecraft begins to slow down. While slowing down, the spacecraft uses its thrusters to help steer toward the landing target. We throw off weights to rebalance the spacecraft so that it's lined up for parachute deploy. After slowing to about Mach 2, or about 1,000 miles per hour, we deploy the parachute to slow down even further. Once we're below the speed of sound, the heat shield separates and the spacecraft looks for the ground with the landing radar. Once Once we reach it at an altitude of about 1 mile, the spacecraft drops out of the back shell at about 200 miles an hour. It then fires up the landing engines to slow it down even further. Once we've descended to about 60 feet above the ground and are going only about 2 miles per hour, the rover separates from the descent stage. As the rover is lowered, the wheels deploy in preparation for landing. Once the rover is on the ground and touchdown has been detected, the descent stage cuts the rover loose. It flies away, leaving Curiosity safe on the surface of Mars. One of the first things Curiosity does after landing is to deploy the mast, which supports many cameras and instruments. Curiosity shoots a laser at an interesting target. This helps us quickly understand the kind and composition of that target from a distance of up to 30 feet. If the target's worth a closer look, Curiosity can drive up and inspect it with the instruments and tools at the end of its arm. The drill on the arm allows us to grab some of that rock and deliver it to the laboratory instruments inside the body of the rover. Those instruments can tell us even more about the mineral composition, getting us closer to understanding whether life could have existed on Mars. Curiosity will be exploring the red planet for at least 2 Earth years, and there's no telling what we will discover.
All right, guys, that is it. I will see you next week. Have a wonderful week. I hope it is not near as cold as it is in North Dakota, because it is effing cold.